Hi guys, welcome to my series Let's Learn Apache Spark. My name is Dharamjit Singh and here I am going to share my knowledge about Apache Spark with you and also to learn from you guys. So let's start. So this is the first lesson in this series and it covers basics about Apache Spark framework and the three main libraries: Apache Spark Core, Spark SQL and Spark Streaming. So if you are new to Spark framework, the first question that comes to your mind is that what is Apache Spark? So Apache Spark is an in-memory cluster computing framework which is developed by UC Berkeley and presently maintained by Apache Software Foundation. So when I say in-memory cluster computing framework, what does that mean? So it means that the computations are done parallelly on a large number of nodes or machines in a cluster, and all the operations are done in memory rather than on disk. So it provides performance to the Spark framework. So Spark framework requires mainly two components. One is cluster manager for managing that large number of machines, and the second one is distributed storage system. So before Spark we have Hadoop. So if you are aware of Hadoop, you may know that it uses MapReduce API, which is developed by Google, but it is not as fast as Spark because all the computations are done on disk. So Spark comes into picture, which takes the advantage of the fact that memory is getting cheaper these days. As benchmarking done by Apache Spark Foundation, it is found that the Spark programs are like 10 to 100 times faster than Hadoop, and also it is like only 1/10 of the code that is written for Hadoop applications. So apart from the performance, what are the other factors that are contributing in Spark getting popular? The first thing is that it supports all the major languages like Scala, Java, Python, R. So it is delight for developers or the programmers with different background of programming. Also it gives you power because its API is very rich and it supports all the major functions that are required to do computation. And the third thing is that it runs everywhere. So let's start looking at Spark API. So in Spark, as you see in this diagram, there are like 5 major components. So the foundation is Spark Core API, and over that we have 4 different APIs for some specific purpose, like Spark SQL when we are interacting with some databases. Then we have Spark Streaming if we want to do some processing over streams of data, and this data we can get from Twitter or some messaging server. The third one is for doing machine learning, we have MLlib, and from doing graph computing we have GraphX library. So let's look at the foundation of the Spark framework API, which is Spark Core. So this API uses a data structure called RDD, or a resilient distributed dataset. So it is a read-only multi-set of data items distributed over a cluster of machines, and it is maintained in a fault-tolerant way. By fault-tolerant I mean, if in process or in computation, if a RDD get damaged or corrupted, it can be created again by looking at all these steps. So RDD provides distributed task dispatching, scheduling and basic IO functionalities. So we have learned about that in Spark Core we have RDD, which act as like a major data structure. So let's see how we can create them and what are the operations we can do on them. So we can create RDD from text files or JSON files, and we can also create RDD from already existing collections. So first example here I have shown how to create RDD from existing collections. Like we have an array of 5 numbers, so we can use the parallelize method and we can create RDD. So here SC stands for Spark Context. So as this is a basic overview of Spark, so I haven't covered much coding here. So in our future lessons we will see what a Spark Context is, but as of now just think of it as like context we used to create in Java Servlet application. It is like a configuration object. And the second example is for creating RDD from datasets. So here we are using a text file to create RDD. So what operations we can do RDD? We have RDDs, and now what to do with these RDDs? So mainly two type of operations are there: transformation and actions. Transformations means like from the existing RDDs how we can create new RDD or how we can transform them, and by actions means how we can get the end results that we want to achieve. So let's see both of these in our example. So we have created an RDD lines from a text file called data.txt. Then we transform this RDD into a new RDD called line lengths, which is simply for creating which simply stores length of every line. And here we have used a map function. So from this RDD we can reduce the total length of the file by using a reduce method. So the next API we are going to talk about is Spark SQL, which is used when interacting with databases, or if we have some data in tabular form in data files. So this API let you query structured data inside Spark programs using either SQL or similar data frame API. It provides access to a variety of data sources including Hive, Avro, JSON, JDBC, etc. So if we have to use Spark SQL, we have to first create a SQL context, which we can create from Spark context as shown in this image. So there is a concept of data frames. So we can create data frames from two sources, like a data source, some JSON file or some text file which contain data in tabular form, and the other is creating data from creating this data frame from some table. If we can connect to Cassandra or some other database, and we can get the data of that table into our data frame as shown in this example, the second example. So once we have data frames, what we can do from that data frames, we can do all the processing that we used to do in our relational databases, like in MySQL or Oracle. We can get the data by the show method. We can select a column of the whole data using select method. We can group by some column, or we can filter some column. So this is like the operations that we can do in SQL, we can do here in our data frames. So the third API is Spark Streaming. Spark Streaming is an extension of Spark Core API that enables scalable, high throughput, fault tolerant stream processing of live data streams. So data can be ingested from many sources like Kafka, Flume, Twitter, or ZeroMQ messaging server. So in Spark Streaming we have dstream or discretized stream, data structure which represent a continuous stream of data. The stream is represented internally as a sequence of RTD. So here in this example I have shown how we can create the stream. We can create a configuration object, and from that configuration object we can create streaming context. Similarly, as we create SQL context in Spark SQL frame API, here we have to create a streaming context. So from that streaming context we can create dstream or discretized stream using this shortcut text stream method. So the other two APIs, MLlib and GraphX, we will cover in our future lessons. So this episode covers very much basics. In the future lessons we are going to see more code, and we will cover internals of Apache Spark frameworks. So let me know if you have any questions. You can mail me at my email ID, or you can post your comments in the below section. Thank you very much.